Good
morning, ladies and gentlemen. Thank you, first of all, for inviting me here. So I am from Jiangnan University. It used to be Wuxi Light Industry University. So I will talk about shelf life prediction. This is a traditional topic and very important and basic topic in packaging of food. Do this manually. First of all, I'd like to briefly introduce our university and our division. So this division was one of the first in China, and we have master level and doctor level classes. And the subject that we touch upon are like food packaging technology and safety. This is something that what we are now currently very interested in terms of its technology and safety. This is the importance is only next to medicine. So food packaging is representing the trend of the area, and the second one will be the logistic, and then packaging mechanics. That's also something that we have been doing research for many years. We have a long history in this topic. And then packaging material and product, starting from its material and then the procedures and then the products. So these are the three main areas of research. So I would like to divide my speech into the following three parts. Food packaging development direction.
And then I would like to show you the research progress on food shelf life. And a third is the optimization of food packaging. First, on the trend of food packaging. We know it's about using the material, finding the structure and the craftsmanship. So it's about material structure and craftsmanship or technique. Food packaging needs to meet certain standards. It needs to be time sensitive, and food packaging, of course, is under close regulation by the government with different new rising requirements year after year. For instance, requirements on shelf life, requirements for logistics. For some foods, it has longer required shelf life than others. So you need to meet those requirements by packaging. And then food packaging is a very complicated issue, which I'll come back later. And then need to be multifunctional. It's more than just packing a food. It has other functions attached to it. And also food packaging has its social features, or as a packager you need to shoulder some social responsibility. So on the general direction, you need to be safe, of course. You need to keep the food fresh and make it convenient. Another trend is smart packaging, and sustainable packaging is also a new trend here in China. Also, people are requiring packaging to have more functions. In particular, fresh foods that need to be translated over long distance. You need to provide better packaging solutions. Food, in order to be sold in stores, must have proper packaging. So you can never talk about food industry without talking about packaging industry. So some people are talking about combining food processing and packaging. Another interesting trend is the role of biotechnology and genetic technology in food packaging industry. So you could see food industry relies heavily on packaging. International trend is active packaging. And another is smart packaging or intelligent packaging. Let's look at both. On the left is the active packaging. So it's about active technique, using active technique to protect and preserve food so that it's safe and affordable. But on the right hand, you see intelligent packaging. That is how we monitor food during the entire process, in particular during logistics. And how do we monitor shelf life? So if we could do both, we are looking at a very promising future. Now, some theories and methodologies of food packaging. I know this is going to be very boring. I hope I will make sense. What is shelf life to begin with? IFT has a very clean definition. It means the time period during which food safety is guaranteed, and it should be in compliance with the product label. So it's about timing. It's about a period of time during which the food safety is guaranteed, and its nutrient features are consistent with the label. On the left, you see with the parts of shelf life, the declining of quality. Well, on the right hand, you see from manufacturing to logistics to storage time and where the shelf life is. So it's all about food quality. A food is composed of different chemics. So, and as time goes by, the chemicals might change, might decrease or increase. So it's not necessarily stable. It will change over time. For most food, its quality tends to deteriorate with time. So how do we make sure that the food is in compliance with the label in terms of the nutrition it's going to provide? So you need to capture the key features of the food and provide its shelf life. So from food to package to environment, let's look at the relations in between. Package is something that lies between food and environment. It preserves the food. It's a barrier. So it delays the impact that the environment is going to have on the food. So there might be some interactions between the environment and the barrier. You may want to use some attractive feature in this packaging material so that it's going to attract bad environmental impact. Also, we are talking about dissolvents. Sometimes oxygen is seen as a dissolved matter that's going to be absorbed by the food via the package. And between, of course, everybody knows the relationship between the food or product and the packaging material. So this is a very complicated issue, as you can see. Now the theory and method of food packaging shelf life prediction. Internationally, many people use this shelf life method. We use experiments to predict the shelf life of products. This is, of course, necessary, but this is a very complicated issue. I may not be able to cover them all in the presentation. If you look at how the quality of food changes, you need to understand how it changes. And you need to predict how the change is going to take place in the future. And you need to quantify the change. You need to have the so-called model. Because without a model, it's difficult for you to predict the shelf life. For certain foods, it's very difficult to predict the shelf life because such a model is impossible. How do we prolong the shelf life via packaging is something that we need to consider. And of course, you need to understand food quality. Now, the status quo of shelf life packaging, these are the main trends or the main methodologies. The ASLT methodology is being widely applied. It's based on the control of humidity. This is a basic methodology because it's very scientific, so it's easier. And a second control is based on the oxidation of fat, high-fat product. And third is based on the control of microorganisms. by predicting the growth and remains of microbials or microorganisms, you predict the shelf life. In the US, FDA has a full list of the microbials that food producers need to look at and consider, and other controls, for instance, the control of food color or the SSL control. These are more difficult criteria because they are hard to be quantified and hard to be measured. In particular, the sensation side is very hard to be assessed. So many researchers will be needed in this area. I need to point out that most of the researches are taking place in the food industry. It's largely about how the environment impacts the food. For instance, its pH ratio. However, very few researchers have taken into consideration the packaging element. However, this is something that's being overlooked because you cannot predict the shelf life without considering the function of the packaging. So far, the majority of the study is mainly on the food rather than the packaging. However, some studies are also being carried out on certain types of packaging materials to predict food's shelf life. Well, this is what we do in the industry. We use this ALST experiment to experiment and predict. We build mechanics models for the food. We find the correlations and we try to figure out the shelf life. So this is more or less the same with different types of food. We build models, we predict shelf life. Three basic measures. Three basic measures.
We're doing some very fast ASLT test. So one is about the initial velocity, and second would be dynamic model, how you make predictions about its early change or early development. And that's very important. For the second dynamics modeling, this is putting all the different chemical elements change under different conditions, and we use different measures to find out the possible change. And sometimes we also combine these two methods, especially in new product development. So that's the current trend where you combine two or more methods. And in the process, Let's see the effect of acceleration ratio on the shelf life prediction. Because we want to use this method to find stable and reliable the statistics. Because if you have this test, if this acceleration test need to take several months, then it's very costly. So if you have a model to predict that, that would be a great way of cost saving. So if you have this method, but there might be some discrepancy. For example, if you use line slope, then you would have the discrepancy. So you will see the discrepancy in shelf life compared with your line slope. And then you will see the higher the accelerated rate, the bigger discrepancy is. And then in kinetic parameter, the discrepancy would be smaller, a lot smaller. So then how you get your data would be very important to the accuracy of your final conclusion. So this is something that we need to pay a lot of attention to. So for the ALCFT problem, there are many problems. First of all, this is not one size fits all. It cannot solve all the problems. And at the moment, there's no such a model that can express all different kinds of food. Sometimes it can be very, very complex. And this will sometimes complicate things. And sometimes it's difficult to quantify things. Like the look, of course, you can grade them, but it's still very difficult to quantify. And you cannot create this continual change. You cannot do that at the moment. Or the process can be very complicated. And then you also will be highly reliable. And in the test lab, you will set some of its rules of change. So how you simulate the true conditions of preserving the food, that's difficult. And then in your statistic gathering, you need to control that and try to lower the discrepancy. That's something the companies need to pay attention to. For example, let's look at this one. There are simulated conditions and then the real shelf life. And product manufacturer and the designer, you need to estimate the reliability of your shelf life. And you also need to pay attention to the risk factors of these prediction. The longer the shelf life is, the discrepancy risks will be lower. The shorter shelf life, the bigger the risk. So how you evaluate that, these are the company's concern. And we haven't really think about the packaging. So it didn't really think about the impact of packed. So if you have the packaging factor in, what are the changes? So these packed factors include the material of the packaging and also the structure of the material as well, because sometimes we think about the entire thing, not just about the material itself, and what kind of technology you used. You need to solve these problems. For example, you need to accelerate the factor, the impact on the material itself. So for the conditions, what are the impact on the packaging material? So these are all something that need to be considered. And also whether there will be interaction between the material and the food. Sometimes this is good, sometimes it's not good. So this will also have an impact on the shelf life. And also you need to evaluate how big the effect is. And then you also need to think about the change, dynamic change or exchange between the material. So all these factors need to be factored in, like the material, the property of the material, its industry procedures, etc. This is difficult, but we need to move on. Let's give you some examples. For example, this one, nylon. This is water permeability. With the change of your preserving condition, for example, IH change or other change, then the water permeability will increase. So you need to give full consideration in your acceleration test. Otherwise, you will have very big discrepancy. Sometimes it fluctuates a lot. And then you can look at the right page. We will do a comparison. If we only talk about the permeability with the change of the conditions, if we do not think about the permeability, then you will see that discrepancy will be very big. One is keep it constant, the other is changeable. So you will see that the shelf life result would be very different. So would this be safe or would it be dangerous? So if it's safe, that means it's probably acceptable. But if it's dangerous, this might be a big problem. It may not be feasible at all. And let's see another example, a PT bottle for soft drink, 2 liters. The initial pressure is 4 atm. When the time goes by, the temperature changes. You see at 20.9 degree, you will see that the pressure changes. In 300 days, it dropped to 3.6 atm. It's come to the threshold. So if it's 29, 200 days, it dropped to 3.2. So environment has a big impact on packaging material. So these factors are important. For example, these things are put on the shelf. There will be light. What are the impact of the light? How does it impact? the packaging. Some of the materials are light resistant, but the effect is variable. So in the long term of being exposed to light, would the material age? That's something needs to be considered. So therefore, shelf life prediction becomes even more complicated. Now, let's share with you some of the research projects that we have done in the past. First of all, we did this multi-component food moisture-proof packaging. You know that we have more and more multi-component food, like a sandwich, biscuit. So compared to the single food, then it's more complicated because the food itself sometimes has interaction. So it will then has impact on moisture. So this is moisture-proof packaging challenge. So first of all, we have a theoretical research on the moisture-proof packaging. For example, for 2-component or 3-component models. And based on this model, we have this prediction model for multi-component.
食品之间要进行相互的这个水分的这个交换，同时呢，食品跟包装的顶空之间还有相互的一个交换。那这个交换过程中，我们怎么基于现有的一些理论跟试验来获得产品，特别是低水分食品的里面的低组分食品的这个水分活度的这样的一个增加的这样的一个规律，因为最终我们可能需要控制的、关心的，可能主体是低组分，就是低含水量要求的这个组分食品，它的一个获奖期，这个里面是它的一个关键了。第二个呢，就是多组分食品里面还有一个我们使用多种数据化，我们对这个
And we used many measures to study how water penetrate such multi-component food. We try to mimic and establish a model so that when in the future trying to predict shelf life for multi-component food, we are more experienced. Those who produce this kind of food, like sandwich, biscuit, must understand what I'm saying. It's difficult to predict shelf life for such food. And we are also predicting the shelf life for antioxidant packaging. These are all the chemical formulas. We look at the penetration of the packaging material, and we also study how the different colors of packaging material is going to be is blocking out sunshine and what kind of effects that would have on food. We see lots of food on display outside this conference room. For some bottles, you see the label covering in the entire bottle. And you want to have the right color for that bottle. Aside from being attractive or beautiful, the label needs to block out sunshine in order to have longer shelf life. And this is how we predict shelf life based on illumination lipid food. So it's similar. We carry out experiments, we build models, and this is shelf life prediction of antioxidant packaging. We do that on soft drinks. And we also conduct a comprehensive analysis of food, lipid, and antioxidant package. You need to factor in lots of elements: temperature, light, the barrier feature of the packaging materials, etc. So far, it seems that light has a lot of impact on food lipid. Or light will strongly impact on how lipid is oxidized. So we look at how the packaging has buried out the light. And this is prediction based on food microorganism control. We measure the oxygen and carbon dioxide within the packaging. But this is very difficult. I'm not going, in the interest of time, I'm not going to go into further details. And we are trying to develop softwares to predict shelf life for different foods. Sometimes you can just not manually calculate how long this food is going to be preserved. So a software is necessary. Sorry if I'm taking longer. Future emphasis and challenges. We are still going to focus on ASLT model. And we are going to be focused on smart packaging, how its shelf life can be predicted, and how dynamic or active packaging is going to impact food's shelf life. And also, there are other challenges and other questions. How long can a food be preserved once it's opened, for instance? How can we predict the shelf life for something that's already opened? This is another thing that you need to consider. And food packaging optimize. Many things need to be taken into consideration. For instance, logistics, sales cost, convenience, and environmental pressure. They all need to be taken into consideration to optimize food packaging. This is on the consumer side, but on the producer side, all you need to consider is shelf life. And this is a survey indicating people are asked to rank, manufacturers, packers are asked to rank the important factors that they think. First, to reach certain shelf life, manufacturers need to know what kind of material they want to use. You need to choose the right kind of film, or maybe multiple layers of fumes. So it's a lot of theoretical work. And we are doing this MAP design. Sometimes you need to put holes on these fumes manually in order to selectively penetrate certain kind of air. He speaks through something he's not given to the interpreter beforehand. And this is about thermal packaging. How to calculate the shelf life of something that's thermal packed. And these are the models and theories that we suggest. We've been working closely with an international food producer to develop some food packaging that's suitable to be sold in high latitude places. Because there, for instance, on high mountains, food packed, the package or the bags will swollen. So sometimes you need to design, you want to have certain holes on the bags so that there will be air ventilation, then the bags will not swollen or will not explode on those very high mountains. So we are carrying out this experiment with that international food producer. Sorry for taking longer than expected. I'm sorry. Thank you for your attention. Well, thank you for that